In our last couple of videos, we've been talking about the concept of the mole. We know that 1 mole equals 6.02 times 10 to the 23rd representative particles. But what we want to talk about now is how much does that weigh? Well, it would depend on how, a mole of what things. A mole of bowling balls would weigh a lot more than a mole of feathers. How much would a mole of carbon atoms weigh? So this is what we kind of want to talk about. And if you remember, I've talked about this number before. Remember, we have a proton or a neutron, either one. We'll call those nucleons, tiny little particles. We have assigned them a mass of 1 atomic mass unit. We made up a unit because these are so incredibly tiny that we didn't want to have to put it into grams, so we called it an atomic mass unit. Well, this mole number is an important number because this is actually how many atomic mass units would equal 1 gram. So if you have 1 mole of atomic mass units, you're going to get 1 gram of matter. 1 gram of matter. So that means a mole of protons or a mole of neutrons or a mole of nucleons would equal 1 gram of matter. So if we think about this, and we think, okay, what if we have 1 mole of carbon atoms? Well, that won't weigh a gram. That'll weigh more than a gram because a carbon atom is bigger than a single proton, right? So 1 mole of protons would be a gram. So 1 mole of carbon atom is going to be something bigger than that. Well, how much bigger than that? Well, what is a carbon atom? A carbon atom would have 6 protons in it, and it would have 6 neutrons in it, right? For a total of 12 particles, or 12 AMUs. So the mass of a single atom of carbon, 1 atom of carbon, is 12 atomic mass units. 12 atomic mass units. It's very small. But what if I had 1 mole of carbon atoms? That would mean I'd have a whole lot more of these atoms. I'd have 6.02 times 10 to the 23rd of these atoms. That's a lot. And each atom here has 12 particles in it. So if I had a mole of carbon atoms, that would mean I would have 12 moles of particles. Right? If I had a mole of carbon atoms, I'd have 12 moles of particles. And each particle weighs AMU, which means I would have 12 moles of AMUs. Well, if 1 mole of AMU is 1 gram, 12 moles of AMU would be how many grams? You guessed it, 12 grams. So this number actually makes life very easy for us. If I ask you for the mass of an atom of carbon, you would just look on the periodic table. Now in my class, we're just going to round it to the whole number. So although it says 12.011, we're going to always round our masses to a whole number, and it's just a matter of sig fig. So we're just going to keep it simple and always go to the whole number. So the mass of a single atom of carbon would be 12 atomic mass units. But the mass of a mole of carbon atoms would be 12 grams. The mass of a mole of carbon atoms would be 12 grams. We just look on the periodic table at carbon, and we see what the mass is, but instead of writing the units atomic mass units, we write down the units grams. Okay, so let's look at another one. How much would a mole of copper weigh? If I had a mole of copper, for instance, if I put a penny on a scale, it'll say that the penny is about like 2.5 grams of copper. You think that's a mole of copper atoms or not? Is there a mole of copper atoms in a penny? Well, if you look up copper on the periodic table, you'll see that an atom of copper, one atom of copper, weighs, if I round it, 64 atomic mass units. So what would 1 mole of copper weigh? Well, it would weigh 64 grams. 1 mole of copper equals 64 grams. So you can see that we don't quite have 6.02 times 10 to the 23rd atoms of copper in a penny, because a penny is only 2.5 grams. Now, if the penny weighed 64 grams, then we would know that we have 6.02 times 10 to the 23rd atoms of copper in it. Okay, what about water? Would I be able to swim in a mole of water? Would you be able to swim in a mole of water? Well, one molecule of water weighs how much? Well, if you look in the periodic table, oxygen is 16. Oxygen is 16. Hydrogen is 1 each, so that'd be a total of 2, for a total of 18. A molecule of water weighs 18 atomic mass units. So 1 mole of water, we're trying to see if we could swim in 1 mole of water. Well, 1 mole of water would equal 18 grams. So no, that'd be pretty ridiculous. There's no way we could swim in 18 grams of water. 18 grams of water, of course, is 18 milliliters of water. 1 gram is defined as how much a milliliter weighs, so 18 grams is 18 milliliters of water. There's no way we'd be able to swim in a mole of water. Let's do one more. Would it be good to salt my mashed potatoes with a mole of table salt? Should I or should I not salt my mashed potatoes for dinner with a mole of table salt? Well, one formula, this is ionic, 1 formula unit of table salt would equal, let's see, Na is 23, chlorine is 35 from the periodic table. So 1 formula unit of NaCl would be 58 atomic mass units. So 1 mole of table salt, let's see if I should salt my mashed potatoes with 1 mole of table salt, it would be 58 grams of salt. Clearly, that would probably be deathly to salt my mashed potatoes with 1 mole of sodium chloride. I don't want to put 6.02 times 10 to the 23rd formula units of salt on my mashed potatoes. That would be 58 grams of salt. That would be a lot. Okay, so that's how we can find the mass of a single thing, or we can find the mass of a mole of a substance. A couple vocab terms I want to kind of show you here so that we don't get confused. I don't like these, and I don't tend to use these, but you should know it. If I'm trying to find the mass of a mole of copper atoms, then I call that finding the gram atomic mass. And if we just look at a copper atom on the periodic table, we're looking at the atomic mass. But if I'm trying to find the mass of a mole of copper, then we put this unit on it. We call it gram atomic mass, the gram atomic mass. That's a GAM, sometimes abbreviated. If I'm trying to find the mass of a mole of water, we would call that the gram molecular mass, or the GMM. So for covalent compounds, this one here is like basically for elements, And this one here would be for covalent compounds. And for ionic compounds, if I wanted to find like the mass of a mole of sodium chloride, it would be the gram formula mass. The gram formula mass, abbreviated GFM. The gram formula mass. However, so that's for ionic there. I don't tend to use any of these terms. I just wanted to mention them because sometimes you see them in textbooks, or you might have a chemistry professor use these. Gram atomic mass, gram molecular mass, gram formula mass, but you calculate them all exactly the same way. You look them up on the periodic table and you put the unit grams on it. So whenever you do the same 3 different things for the same thing, I think that's kind of ridiculous. So I call all of these calculating the molar mass, which of course is the name of this video. The molar mass. So I'll say, what's the molar mass of copper? What's the molar mass of water? What's the molar mass of table salt? And you're trying to answer that question. You're figuring out, calculating from the periodic table, what is the mass of 1 mole of this particular substance. So we're going to call that calculating the molar mass.